Hey everyone, how's it going? This is Carl and this is Fundamental Statistics in Excel conducting a regression. So I just wanted to give you a basic overview of linear regression, kind of with an example, kind of see how this operation works in Excel, and to give you a broad base as you apply it to just problems as you go about. So what we'll do is we'll drive back right into it. So here we go. Now this data is actually categorized. Typically in linear regressions you'll have a whole series of data points just kind of scattered throughout, an X and a Y. What I've done here is kind of actually recategorized it a little bit. So you have an X value, or what you might call the response variable, or the independent variable rather, and the Y value is the response variable. So you kind of see all the X's that are 1 are lined up, 2s, 3s, etc., whereas the Y is kind of your response variable. So if you think about it as a reactionary standpoint, like you're kind of seeing what the variation is between, does Y have an effect on X, or does X value have at a certain value have an effect on Y? That's really what you're looking at. That's why it's the independent variable. It's kind of on its own. It's consistent. You want to see what's Y's effect. So what we're going to do, go to our handy dandy data analysis tool pack right over here, and we can kind of scroll down. You'll kind of see right up there, regression. So we're going to look at this regression. I'm going to make a regression to see, is there an effect. So what we're going to do is we're going to do our Y input range. Now we already kind of laid it out this way, Y. And as another example, what could you do in setting up this data? You could think about it as if X were cities and Y were hours in traffic. See, X is independent because there's only one, say Dallas or Los Angeles, that kind of thing. And Y is the response variable in terms of, okay, what is the average traffic time in that city based on the data point. To kind of give you a real world example for it. So for Y, we're going to choose here. Okay. Response variable, and our independent variable X is going to be up here. Let's go ahead and start here and go all the way up. There we go. And always very important to do labels. And confidence level is default to 95%, or alpha equals 0.05. Remember, alpha is 1 minus your confidence level. So here, that's why it's 0.05, and 95 is right here. So again, similar to last time, we want to put our output range on the same spot. We're going to put it right around here, just to kind of see what's going on. And what we'd like to do is just kind of give the basic of the basics. So we'll do this. Everything looks fine. Some of these stuff is a little bit more advanced, but we just want the basic linear regression right now. And there we go. We can kind of line it up a little bit, straighten it up a little bit. There we go. Kind of show our output. Alright. So there is a lot of info here. Quite a bit actually. But there's a couple of key important pieces that you want to know. Your slope coefficient. So you want to find out what that slope coefficient is. And after this, just a little bit more. So, the slope coefficient X. Remember, that's that elementary equation Y equals mx plus b. So, it's similar to that. So, they respectively correspond as the slope and the y-intercept of your best fit line. So you can plug them in. So when you think of y equals mx plus b, you think of it to a certain extent. So if you think about it, if you wanted to get a regression equation out of this so that you can plug any value in, your y would be equal to this. I mean, in the sense of your intercept. So remember, y equals mx plus b. Your b is right here, and your actual m, or your slope, is right here. You know, it says x because that's just the value. Your m is right here, and your b is right here. So if you think of y equals mx plus b as an equation for the regression line, you're thinking y equals 0.43 times your x, whatever that might be, plus 73.8. So that's your regression equation based off of what we have right here. The next piece is the p-value for the slope that you can see. So it's right here, 0.88. Just to kind of let you know this information. If this is less than 0.05, then you can reject the null that the independent variable has no effect. So, after all, a positive or negative slope is what you were after. The steeper it is, the stronger the relationship. The steeper the line, the stronger the relationship. So as you can see, we can't really reject the null just yet based off of this and based off of our confidence level, alpha, 0.05. So we're close, but we're just not there yet. So another thing I wanted to touch base with about this is your r squared right here. Now your r squared, this is a number ranging from 0 to 1. It is a measure of how tightly your data fits the best line. And r squared of 1 is a perfect fit, which doesn't happen too often. Ideally, it's really, really, you have to question it sometimes. But in this case, if it's that small, and it looks to be that small just based off of this, then a scientist could say that the independent variable explains 0.0007, or as you can think about it, if this is 0.7 is 70%, 0.07 is 7%. So kind of give you a quick test about this in terms of percentages. So what this means, what I just did was just to kind of give you a percentage standpoint. So r squared, this number means that it explains roughly, let me just format this real quick and it'll be a little easier to read. Actually going back, 0.07%. But this line, our regression line, explains 0.07% of the variation, which really isn't helpful at all. The closer it is to 1, the better it says to explain the variation in your line, which is a good thing. You want to know how much variation there is. And 0 means there's absolutely no pattern or fit whatsoever, which means your line is basically irrelevant, which is what, based on our data points and based on r squared, that's what it is. And furthermore, based on that our p-value is not statistically significant compared to 0.05, or alpha. So I hope this helps your understanding. We hope this helps your understanding. Just let us know if you have any questions along the way. All right, thanks so much.